Good morning, students. How are you? So, today we study about the magnetic effect of the electric current. So, some topic of the this unit are left. In previous lecture, we study about the magnet and magnetic field due to a magnet and solenoid. So here this is magnet and these are the magnetic field of lines. So these patterns are made by the magnet. And another important concept is what is solenoid. So solenoid also produce magnetic field. Both magnetic field produced by the magnet and solenoid are same pattern. So here in previous lecture I tell you this is a artificial magnet and this artificial magnet consists two pole. So this example, this is north pole and this is south pole, and these poles are produce magnetic field and these lines are starting from the north and merge at the south. So important point about the magnetic field produced by the magnet, what these lines are produced from north to south. What is direction from north to south direction, and second inside the magnet. What is inside the magnet, not reverse, that is this is south to north. And second, these lines are more crowded at the poles. So we can say that intensity of the magnetic field at the end of the pole is maximum, and at the center is what is minimum. So, and next, this is the another pattern which show the magnetic field produced by the solenoid. So basically, already I tell you what is solenoid. Solenoid is a circular wire. They contain many turns. So magnetic field produced by the solenoid depend upon the number of turns and how much current produced in a solenoid. So basically, we increase the magnetic field of a solenoid by increasing the number of a turn of a coil, and second by increasing the value of the electric current. And we can increase the value of the electric current by voltage. So if we increase voltage, then electric current increase. And if we summarize this into a formula, so we can write magnetic field directly proportional to electric current and number of turns. If we remove this proportionality sign, so we get what? Mu naught. This is mu naught. So mu naught basically a constant, and depending upon the type of the material used inside the solenoid. So these are pattern produced by the magnet and solenoid. So both are same. So because they contain a lines, and these lines are purely what is imaginary lines. So basically magnetic field is invisible. We cannot see these lines. So this is a imaginary concept. And in next slide, we discuss application of a solenoid. So what are the application of a solenoid? Applications means what are the use of a solenoid? So use of a solenoid basically we use for making a electromagnet. What is making a electromagnet? And already explained how to make a electromagnet. So we take a piece of a like metals, chromium and nickel. So these are the metals, nickel and these chromium, and these are cobalt, and this is iron. So we take a piece of a, so here we take a piece of a metals and put inside the solenoid. So when we put inside the solenoid, we switch on power supply. What happen? Large number of a magnetic lines of force are passed. So these lines are passed like this. So how much over material converted into a magnetic, this is depend upon how much these field lines pass through a materials. So more number of lines are passing through the materials and over material becomes more magnetized. So this is the main application of a solenoid, and use of a solenoid making a use of a solenoid is to make a magnet, and use of a magnet what is used in communication devices, transmitter, receiver, speaker, so many applications where we use strong electromagnet. So next, this is a conductor which plays in the magnetic field. So here we find out how much magnetic field applied force on a conductor. So basically it depends upon the angle between the magnetic field and length. So this is a length of a conductor. And this is what is magnetic field. So this magnetic field what is uniform magnetic field. So this is depending upon the angle. For example, if we place that like at 90-degree angle, we put conductor at right angle. So conductor experience maximum force. Like, so first of all we put conductor at 90-degree. So this is magnetic field. So this is uniform magnetic field. So this is uniform magnetic field, and we place a conductor. For example, this conductor So this is what is conductor, and these conductor having length L. So this is L, length of conductor, and this is also L. And here conductor put at right angle. So what is conductor put right angle to filled lines. So right angle means we put conductor here, what is 90-degree angle. So here what is angle? 90-degree. Second, so here also 90-degree put. So we take another case, here is 90-degree and here put what is parallel at 0-degree. So how to put parallel 0-degree? So for example, here we put this is a conductor, and this length L, and this is magnetic field, and here angle what is 0. So when conductor placed parallel to field lines. So basically here two case, one is conductor is perpendicular and second is conductor is parallel. So in both cases here angle is 90 degree and here angle what is 0 degree. What is 0? So theta is 0. So here magnetic field apply maximum force on a conductor, and here magnetic field of lines apply 0 force on a conductor, because here see most of lines pass through the conductor. Here see this lines 1, 2, 3, 4, 5, 6 and 7. So here 7 magnetic field of lines are present and these are passed through the conductor. So these conductor experience a maximum force. But here we see that these conductors are placed parallel to the field lines and these parallel lines are passed through. So these lines are not passed through the conductor. So here conductor not experience force. So force experienced by the parallel conductor is 0. So here force 0. And here force maximum. So here force maximum and here force 0. 0 means minimum. So basically we can say that force on a conductor depend upon the angle of the conductor and magnetic field. So this is depend upon how we place conductor in a magnetic field. And another example in given NCERT book, what is U-shaped magnet? So we put conductor between the U-shaped magnet and we find out the force on a conductor. So for example, force on conductor when placed in uniform magnetic field produced by U-shaped magnet. So here we take a U-shaped magnet, and so U-shaped magnet produce magnetic field. That U-shaped magnet also known as what is horseshoe magnet. So here we take a horseshoe magnet and we find out force on a conductor. So for example, this is a U-shaped So this is a U-shaped magnet, and we take here conductor, and this conductor like this. So we place a conductor between the U-shaped magnet and this conductor tied with a stand. So this is a stand. So here we find out the force on a conductor. So how to find out? First of all, this circuit is open. So when circuit is open, no current flowing in the circuit. If no current flowing in the circuit, then position of the conductor at the middle. What is? So first we write first case when current 0. So 0 means circuit is open. So when no displacement in rods or a conductor. So this is first point. When circuit is open, no current flowing in the circuit, then position of the rod not affected. This is the middle of the center of the U-shaped magnet. And second case, when circuit is closed, so current flow. So current flow, so direction of a current flow from positive to negative. So here current flow from positive to negative, and we already know if current flowing in a conductor, then conductor produce magnetic field, and if they produce magnetic field, conductor behave as a magnet. What is important point here? Conductor behave as a magnet. So this already, for example, this is north pole and this is south pole. So this act as a north pole and south pole. So we already explained north pole are repel each other and south north pole are attract each other. So this is the condition when circuit is closed and current flowing in the circuit. So what is position of a conductor here? This apply force on here. So they repel each other, and this is south, so they also repel each other. So here what position of a electrode change. So displacement in the rod observed. So we can say force apply on the magnetic field. So how we draw this. So we make position. So position of a rod this. So this act as what is south pole and this act as a north pole. So south attract toward north and north attract toward south. So here position of a conductor or a rod are changed due to the force applying by the magnetic field. So this is case second, and third case, change the polarity. So what is the meaning of here change of the polarity? So change of the polarity means you interchange the positive and negative connection. So here what happened? This is negative and this is positive. So we make here this change. Like this is negative and this is positive. So if we change the polarity of the battery, what happened? Then direction of a current change. So here what is direction of current? So direction of current from positive to negative. So direction this. So direction is reverse. If direction is reverse, this act as a voltage north pole and this act as a voltage south pole. So again, north repel each other and south repel each other. So again, displacement observed by the rod and position of the rod change. So what is the new position? So new position of a rod. So new position of a rod this. This is north pole and this is south pole. So north attracted by the south and this south attracted by the north. So here three case. One, when current is zero, no displacement in a rod or a conductor. Second case, when circuit is closed, current flow. And then what happened? We observed the change in position of the rod. And third, when change in the polarity. So this is the force observed by the conductor in a magnetic field produced by the U-shaped magnet, and that is known as the horseshoe magnet. So we can also find out force on a charged particles and conductor and any like positive particles, proton, neutrons and electrons by this method. And again here question arises, what is the direction of a force? Direction of force. So direction of a force we can find out using right hand Fleming rule. What is? Right hand Fleming rule. So what is right hand Fleming rule? So according to right hand Fleming rule, take your right hand and make your position of a hand like this. So here are three fingers. First is thumb, second first finger, and this is middle finger. So here first thumbs gives the what is direction of a force, and first finger gives the direction of a magnetic field, and this finger, second fingers give the direction of a what is electric current. So how we draw this? So we make this like and this gives the direction of a magnetic field, first finger, and second finger direction of electric current. And this gives the direction of force. So this is right hand Fleming rule. So we can define right hand Fleming rule. According to the right hand Fleming rule, align your first finger in the direction of magnetic field. Align your first finger in the direction of a magnetic field and align your second finger in the direction of a electric current. Then thumbs gives the direction of a force. So we can understand by this example. So we can take an example. So, for example, this is a magnetic field. These are the magnetic lines of force and a charge particle. This is charge particle. This is electron. And this is proton. So they are moving downward direction. So find out force on a charged particle, electrons and protons. So here we use right hand Fleming rule. We already know thumbs give the direction of a force, first finger gives the direction of a field, and second finger gives the direction of a electric current. So here what is the direction of a electric current? Electron move in a downward direction. So what is the direction of a current here? This. So this is the direction of a current. Because we take direction of a current opposite to the electron. So here electron move downward, but direction of a current is upward. So according to your right hand rule, align your first finger in the direction of a magnetic field. So this is magnetic field. Align your first finger in magnetic field, and this is direction of a current. So this is in direction of a current, this in field. Then thumbs gives the direction of a force. So here what is force in outward direction? What is force? Force acts on electron outward direction and perpendicular to the board. So these electrons are deflected in the outward direction perpendicular to the board. And second here proton consists what is positive charge. So here direction of a current is I. So we need two things, field and current. So here what is this? Is field. So this is magnetic field and this is electric current. So electric current in downward direction and magnetic field in that direction. So what is direction of a thumb? So direction of a thumb is into the board. So here force act on a charge particle into the board and this is perpendicular to the board. So force act into the board and perpendicular. So these numericals many times come in board exam and every year comes. So this very easily you know, you learn right hand Fleming rule and applied and you can find out the direction. So we complete our lecture here and some topics left to discuss in later slides. So thank you very much. If you have any suggestion then put in your comments box. ठीक हो गया सर। अच्छा।